In this video tutorial, you will learn how to set analog inputs and measured values. Next we will consider setting in the Configurator software. Similar settings can be made in the Smart Monitor software. Before starting to work with the configuration, it is recommended that you watch the video tutorial opening and saving of configuration file. After successfully opening the configuration file in the project tree, select the Analog Inputs section. The tab that opens contains the list of analog inputs and the setting area of the selected analog input. Analog measurements are used as input data in the operation of protections and in the formulas of calculated values. Analog measurements are of the following types. Real, displayed in the list in black, are measurements of the values connected to analog inputs of the IED. Calculated, displayed in red in the list, are measurements that are created from other measurements using a specific function. Virtual, displayed in the list in green, are measurements that are created on the basis of real measurements, but with the ability to specify other basic values, transformation ratios and signal transmission parameters to PCS. Telemetry, displayed in brown in the list, are measurements received via digital data transfer protocols, except for the sampled values protocol. Real measurements can be added by pressing the appropriate button on the toolbar. In the window that appears, specify the name and select the required type. When selecting the phase or linear types, you can add a group of 3 signals at once or only one signal. By selecting to add one phase, phase A will be added by default if the phase type is selected, and AB if the linear type is selected. Next, we specify the module of analog inputs. To speed up the setting, you can add all the analog signals of the unit by checking the appropriate box. This will create real measurements, grouped by 3 phases, for all module inputs. It is also possible to add calculated and virtual measurements by opening the context menu with the right mouse button. For newly created measurements, all parameters have default values, so we recommend that you set them yourself. For example, let's set up a real measurements. Parameters name, phase name, and mode are preset at the factory and can be edited if necessary. The type parameter in this case is informative. The base value is used for the correct operation of protections, the settings of which are specified in relative values. As a base value, as a rule, the rating of the secondary winding of the instrument transformer supplied to this analog input is indicated. The transformation ratio is necessary to determine the primary measured values, when displayed in the Smart Monitor program and on the display of the IED, as well as in the measuring elements and when calculating the switching life of the circuit breaker. The display parameter is responsible for displaying the analog input in the IED and Smart Monitor software in the disturbance recorder, current values sections, as well as in generated reports on communication protocols. This parameter is used if the analog input is used only in protections or measuring elements and there is no need to view its values. The sensor and sensor output parameters display the module of analog inputs and the channel number from which the measurement is made. If the SV stream receiving module is selected for the sensor parameter, then the received SV stream is displayed for it in the ASDU parameter, and the signal of this SV stream is displayed in the sensor output parameter. The rated value of analog inputs of the ED2 IED is specified programmatically by selecting one of the available values in the drop-down list. For each of the items in the list, the rating and measurement range of the value are indicated, in which the measurement accuracy is guaranteed. Based on the value of the secondary circuit of the transformer, we select the value of the input of our sensor. If necessary, for example, in case of an error in the installation of secondary circuits, it is possible to programmatically turn currents 180 degrees. In order for the analog input to perform measurements, you must check the Create Phasor field. If the analog input is used in some kind of protection, then the phasor will be created inside the measuring element, and this parameter does not need to be specified. If the configured analog measurement is not used in protections, but, for example, is intended for transmission via MMS reports, then a phasor will need to be created for it. Also, when creating a phasor, we specify for which harmonic the phasor is created, and at what processor count for the period of industrial frequency it will be calculated. In the signal transmission parameters to PCS area, set the deadband either as a percentage of the base value or in absolute values. When you specify one value, the second will change automatically. The dead band determines by what value the signal must change in order for its updated value to be transmitted over digital communication protocols. It is also possible to add alarm and validity thresholds for transmitting values via the IEC 61850 MMS protocol. By enabling the function and setting the thresholds in relative values, the transmitted value will have a marker belonging to one of the ranges. In addition to similar parameters of real measurements, the calculated measurement setting area displays the function and analog inputs, on the basis of which this function performs calculations. For example, if phase voltages are connected to the IED, and line voltages are needed for measuring elements or protections, then it is possible to create calculated measurements with voltage conversion by subtracting two phases. Setting virtual measurements is similar to setting real measurements. And for telemetry measurements, the ability to select a virtual module and its input is available. With the help of a virtual module, analog values are received via digital communication protocols. You can learn more about setting the reception of analog signals via Goose protocol in video tutorials Goose, MMS protocols of IEC 61850 standard. It is also possible to combine single signals into groups. Group signals have the same base value and transformation ratio. Combining into three-phase groups is used when binding to measuring elements and in calculated values for calculating some electrical parameters, for example, three-phase power. To combine signals into groups, you need to open the grouping editor. Buttons are provided in the upper part of the editor for creating and deleting signal groups. Let's add a new group by clicking the Add button and transfer ungrouped signals to it. Note that all signals added to the group will take on the name of the first added signal. The next necessary adjustment is to group analog signals, 1-bay, into a frequency group. To do this, open the editor of frequency groups. The use of separate frequency groups is necessary if the frequencies of input signals may differ, for example when measuring voltage on the sides of a circuit breaker. Also, separate frequency groups are required for measuring elements that measure the frequency of the input signal, or that must provide high measurement accuracy when the frequency deviates from the rated value. By default, all newly added signals are in the zero frequency group. Zero frequency group signals can be used for measuring elements that do not perform frequency calculations. To add a new frequency group and delete an existing one, you can use special buttons or the context menu. Add a new group by clicking the Add button. You can also change the name of the created frequency group through the context menu. Next, we will move the signals of 1-bay to the created frequency group. If these are group signals, for example, 3 current phases, then, by moving one signal, all phases move into the group. After adding signals to the group, the first of them becomes the base one. The frequency of all signals in the frequency group will be equal to the measured frequency of the base signal. If possible, we recommend using line voltages as base signals, which will ensure correct measurement of the network frequency in emergency conditions such as, for example, single-phase earth faults. If phase voltages are connected to the IED instead of line voltages, then it is possible to use the algorithm for determining the frequency from the calculated line voltages. To do this, select item Determine Frequency by Calculated Linear Signals. You can check the correctness of settings by loading the configuration into the IED and applying currents and voltages to the corresponding analog inputs. To learn how to do this, see the video tutorial Viewing Measurements, Status of Inputs, Outputs and Logic. This completes the setting of analog inputs. The created analog inputs can be used in measuring elements. To do this, open the Measuring Elements section. In the tab that opens, select the measuring element. The Inputs area displays a list of measurements required by the measuring element and the corresponding analog inputs. We indicate the analog inputs we created instead of them. Setting other parameters of measuring elements is not considered in this video tutorial. The Calculated Values section allows making calculations of capacities, frequencies and other calculations on the basis of analog measurements of the IED at the discretion of users, and it is possible to use logic signals. The values of calculated values are available for viewing via IED menu, and they can also be placed on the mimic diagram. For an example of setting a calculated value, we will correct one of the already created ones. Let's specify the name, for example, the active power of phase A, and indicate the measurement unit for it. There are two ways to specify the unit of measurement: select it from the drop-down list, or open a window with measurement units grouped by type. Next, open the editor to set the formula. We open the menu with a list of functions using the key combination control and space. For convenience, you can use the search bar. From the remaining functions in the list, select the one you need. Then we set the cursor between the quotes and indicate the signals of analog measurements. The list of signals is also opened by the key combination control and space. Analog measurements are made in secondary values, so the received power must be multiplied by the current and voltage transformation ratios. To do this, use the keyboard to enter the multiplication sign and again open the function list and select the function of the transformation ratio. Specify the name of the current analog input, the transformation ratio of which we need. Similarly, we introduce the voltage transformation ratio. Since the unit of measurement is megawatt for the calculated value, we divide the result by 1,000,000. If the syntax is followed when specifying the calculated value, the background of the window will be white. If the background of the window is red, we recommend that you check the formula for errors. By clicking on the Help button in the upper right corner, you can see examples of formulas and set variables. Next, we specify the format for displaying the value on the IED. To do this, open the Display Format editor. In the window that opens, set the number of digits of the fractional part of the calculated value, which will be displayed on the IED in the Current Values menu item. We recommend that you specify the display format based on the required accuracy of the calculated value. If the quantity of symbols in the number is greater than the permissible quantity of displayed symbols in the value column, then the number will be displayed as a scrolling text. To display the calculated value on the display of the IED and in the Smart Monitor software, you must check the Calculated Value display box. If it is necessary to record the calculated value, check the box in the corresponding column. In the Calculated Value Parameters window, you can change the smoothing factor to reduce the influence of the pulsing of measured analog measurements on the calculated value. The factor value is specified in the range from 0.01 to 1. For example, a factor of 0.1 means that the calculated value during the next recalculation will change by 10% of the difference between the new and previous value. With a factor of 1, there is no smoothing. Specify the maximum calculated value. The deadband value is calculated relative to it. And the deadband itself can be set either as a percentage of the maximum value, or in absolute values. When you set one value, the second one will change automatically. The deadband determines by what value the signal must change in order for its updated value to be transmitted over digital communication protocols. It is also possible to add alarm and validity thresholds for transmitting values via the IEC 61850MMS protocol. By enabling the function and setting the thresholds, the transmitted value will have a marker belonging to one of the ranges. Calculated values with logic measurement unit set can be transmitted to the logic diagram. After checking the corresponding box for the calculated value, the calculated values buffer will appear in the logic diagram. You can learn how to work with logic signals in video tutorial binary inputs, outputs, logical signals and indication. If necessary, you can change the recalculation period for calculated values. To do this, in the corresponding field, enter the required value in the range from 100 to 30,000 milliseconds. This value will determine the recalculation period for all calculated values. For an IED with the functions of a Bay controller, it is additionally possible to add and delete calculated values, as well as change their position in the list. You can check the correctness of settings by downloading the configuration to the IED and applying the necessary signals to corresponding terminals. To learn how to do this, see video tutorial viewing measurements, status of inputs, outputs, and logic. To be able to quickly change the variables of calculated values, the settings of measured values are provided. For example, they can be used to compare the calculated power with the setting of the calculated value, and if the setting is exceeded, generate a signal into the logic circuit. The function of using the setting in the formula of the calculated value is called calculated value setting, respectively. To adjust the setting specified in this calculated value, open the Calculated Value Settings section. In the tab that opens, specify the setting value. The setting value can be quickly changed via the front panel of the IED or using the Smart Monitor software. To learn how to do this, see video tutorial Changing the Settings. Comparison of setting groups. You can also specify the permissible maximum and minimum setting to limit their adjustment via Smart Monitor. For ease of use of the setting, we recommend that you fill in the description field. Adding and deleting settings is also only possible for IEDs with Bay controller functions. When editing is complete, you need to save it using the File menu or by clicking on the Save button on the toolbar. This video tutorial is over. We hope it was useful to you. Thank you for attention.